Hey everybody, this is Larry. This is day 5th of May. Cinco de Mayo. Wow, time flies. Maybe I should do something. In any case, yeah, hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem on Discord, which is on Jump Game 2. Well, the poem is Jump Game 2. I need a haircut. Always playing around my hair too much. Anyway, so I usually stop these live, so feel free to fast forward, watch a 2x, whatever it is that you do. But anyway, so given non-negative nums, you have the first index, and you want to get to the last index in a minimum number of jumps. You can assume that you always reach the last index. Okay. So n is 1,000 is interesting because that means that n squared is doable, and that makes it, to be honest, that just makes it trivial, right? Because that means that for each index, you can look at every other index, and n squared is going to be trivial. So I'm going to spend a couple of seconds to think whether there is a way to make it a little bit better. Is that the jump from or jump to? So what does that mean, right? So that means that, so basically the idea is that, okay, for example, you have 3, you could jump to 1, 2, or 3, but the maximization, like if you want to think about dynamic programming, and that's what I'm trying to do now, if you have a given index, you maximize over all the previous jumps. But of course, you also want to do it in a way that doesn't take all of n times, right? Because that's the way that we're going to end up doing it for this problem, possibly. Because if it's n square, that's trivial. Not trivial, but like for dynamic programming problem, it's relatively understandable. I don't know. Because you can do maybe there's some kind of heap type thing that you can do with respect to queue-based defense, because I think definitely you can do it, actually, because I think you can have a heap of things that reaches this state, and then you can pop them as it is no longer reachable with the value, right? So what I mean by that is that, okay. Yeah, so that's going to be n log n in that case if you do the heap solution. I don't know that I gave enough details for you to upsolve, but definitely try to upsolve it. But the idea is that, okay, you look at it. Yeah, I think that's actually a cool solution. I don't know if that's a later jump game or something, but if you are able to do that, you do that. But I'm gonna probably focus on just the n square one for the beginners amongst us. You want to leave in the comments or Discord if you want to talk a little bit more about the upsolving of the n log n solution. Yeah, I just want to confirm that I'm saying the right things. Thinking a little bit about the heap solution. I think that's right, though, because then you just basically, you can think about it as a event-based thing where, every jump represents a future time, and then the value is the time to get to that node, right? So then in this case, for example, this 3 means that we're able to, this expires at time, or step 5, if you want to call it that, with the value of 1 or 2, depending on how you want to do it. And when you get to the parsing, you just take the minimization of all the events that you can do. So there's a lot of, not a lot, but a couple of, so there's a heap, and then you have to keep like a, so you have to keep a heap and a set or something like that, but you can do it n log n, I think. I think that's n log n. Yeah, it should be n log n, because because each item will be pushed or popped once. Let me know in the comments or something like that whether that solution is more interesting, because I'm just going to do the n square solution as I talked about. So okay, let's go with the n square solution, right? And I'm going to do this top down. I think actually for this problem it's more straightforward to do bottoms up, but I like to teach doing top down, and then you can upsolve it with bottoms up if you like. But yeah, so then as I like to do with dynamic programming is that I like to define my functions, and I mean that very specifically with what question am I trying to ask here, right? Which is that, okay, min jump of, say, some index, right? And then what does this mean? This means that what is the minimum number of jumps to reach the last index from index. That's a little bit mouthful, but you get the idea, hopefully. And and then this is pretty straightforward in a way. Let's actually also set n is equal to length of nums. So if index is equal to n minus 1, we return 0. Do we return 0 or 1? No, we return 0 because we'll do it in the course. And then now we just do a for loop depending on how many steps we can jump, right? So yeah, for n index, for next index is maybe I'll just write it out because I'm not really in competition mode. So we start from index plus 1 and then index plus nums of index, right? Maybe I'm off by 1 on this, because if this is 1, then yeah, okay, yeah. So this is this because this is exclusive range. So then now we can do also have a min jumps is equal to, let's say, infinity, and then here min jumps is equal to the min of whatever min jumps we have, or min jump of next index plus 1, right? And then now you can return min jumps, and that's pretty much the idea behind. That's pretty much it, really, right? So you start from 0, and then you could run it. This is going to be n squared if you do memorization. Otherwise, this is going to take a long time. Sometimes I will do a long case. I guess this is an easy one to do a long case. So let's do that. Yeah, this is just some like big-ish array. I think that's probably big enough. If not, I'll just add more. Right? Yeah, and as you can guess, this is going to be time limited, say either, because it just takes too long. But the magic of dynamic programming, structuring code this way, is that the first thing to notice is that for every input to this function, we get the same exact output, right? There's no changes. It's deterministic. There are no side effects or anything like that. So, and with that in mind, that means that we can do caching, and that means that, okay, let's just do caching. So first thing to think about is, okay, what are the possible inputs to the index? Well, index can go from 0 to I guess n minus 1 inclusive, right? So then we just have to set that up. So let's say has cache is equal to force times n, cache is equal to let's just say infinity times n. It doesn't really matter because we never use this unless it is used. So then now we go, if this has cache of index, we set that we return the cache, right? This is pretty much self-explanatory. And then at the very end, we just have to remember to cache it. Also, my wrist is better today, in case you were wondering, because I think, well, I mean, yesterday I complained a bit about me typing slowly and stuff like that, and this looks good, so let's give it a, I think that's good enough for me to give it a submit. And of course, that's because I know the complexity. Oh, I made a mistake. I knew this was going to happen, but that's why I thought about doing this, but I forgot. It's a short answer. So this basically goes out of bounds is a short answer. But whoopsie daisies, I was a little bit too hasty. Whoopsie daisy, a little bit hasty. That kind of rhymes. But yeah, because I was eager to kind of explain the other things. But let's give it another submit. I wasn't worried about the complexity, but I guess I should worry about the edge cases. And here we go. And I don't worry about the complexity because, again, let's look at the number of possible inputs. So there are going to be O of n inputs, n precisely in this case. I guess technically more, but it doesn't, because for for most of them it'll be O of 1 because it just returns 0. So yeah, so for the more than n O of n in, though actually this is kind of bad the way that I did it now that I see it, because this could be O of 10 to the 5th, and actually this would time out. So I was just a little bit lazy on the if statement. What I should have done is because this goes through the for loop enough times, right? So what I should have done is something like this, of n. So that's actually the better solution. Because I could have actually eaten another timeout without really, because if every element is 10 to the 5th, then I would time out again. So actually that's a silly mistake on my part, even if it wasn't caught. So yeah. So okay. So the possible inputs are the n possible inputs, and in each input we do a for loop over O of n at in the worst case, especially now that we corrected, is O of n. So yeah, each input takes O of n times. So that means that in total, total time is just equal to number of inputs times how much each input take, and that is just n squared, because we have O of n and O of n. And space, of course, is going to be O of n, just linear space, because you can kind of see, these things here, and also you can count the stack spaces at most O of n, if they're all ones, for example. Yeah, so quadratic time, linear space, and yeah, and this is the dynamic programming solution top down. You can do this bottoms up as well. I encourage you to do it. Yeah, and I think the space optimization should work for this problem as well, so you can actually still do it in with bottoms up n squared time and O of n space. I guess that's not technically in space up, or unless you really do it silly way, it would be linear time anyway. So, linear space. Again, as I mentioned, you can actually solve this with a heap, maybe, to kind of I think that works. Yeah, it's a little bit. Maybe I'll go with that solution at some point, but yeah, let me know what you think. But you can solve this with a heap with an n log n running time, and that's pretty much all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join my Discord. It's good to get one correct. And this week has been kind of weird, right? Because there were 2 hard ones, and then there are 2 easier ones. Oh no, running sum was easy, but the non-decreasing array I spent way long on it was a hard one for me anyway. So it's good to kind of have one that is non-trivial but still easy for me, or at least that I'm able to solve in a good time. That's all I have. As I said, hit the like button, hit the subscribe button, join me on Discord. Have a great day, have a great rest of the week, and I will see y'all later. Keep that mental health good. Bye bye.